Hello, everyone. Welcome to Engineering, Products, and TPM Talks. And for the TPM talkers, builders, and doers, a special welcome. That was my original job family, hence the interest. I know how difficult it is to move from a program management role to a technical program manager role. Challenges. Yeah. So for the TPMs, special welcome. You can reach out to me if you have any questions in the TPM engineering or product space. So this is the third part of the system design series, but this now we're focusing on API designs. Uh, in the previous parts, we looked at the functional and non-functional requirements, and we started to look at the design considerations. Well, we like to start with a thought of the day, and today's thought is from Torquato Tasso, who says, "Fortune rarely accompanies anyone to the door. Fortune rarely accompanies anyone to the door." I think this is spot on. As the late great Aliyah, in the Liyah says, in case you don't succeed, pick yourself up and try again. P.S. If this says something else to you, you have another spin on what fortune really accompanying anyone to the door is. Jump in the comments and let me know below. And as Aliyah said, this is the Liyah. Okay, in case you don't succeed, pick yourself up and try again. So who is this for? I've said a little bit about that. TPMs, product TPMs. We have started design decisions, which is why it's half covered. But in this session, we want to sort of complete that. Right? If you have interviews coming up, inbox me. Let me know how I can help. You don't need to suffer alone. Yeah, recent article from Financial Times. US graduates are facing cutthroat job markets, right? But it's not just graduates, even permanent and long-standing employees. I'm seeing people let go left, right, and center. So yeah, let's work together. Okay. So now I want to talk a little bit about the architectural styles, right? So for the client API gateway, I remember we discussed that previously, and I'll show another picture around that. The tweet service will create a tweet, and then the timeline service obtains a timeline based on the user's request. Okay. Um, Users can update or delete their tweets. And in all of this, typically what we see are the CRUD operations. So for those that don't know, CRUD or CRUD stands for create, read, update, delete, right? So for that reason, quite naturally, you would say REST. The REST protocol is the right choice for communication between the client and API gateway. Uh, Let me know your thoughts if you believe that that is the right call, or you use something else, maybe WebRTC. But for me, I think because of the fact that the operations are mainly CRUD, then we can perform read operations using HTTP verbs, right? That to me is a no-brainer. But again, it's my design. Let me know what you think yours. For the API gateway to the backend service, the interaction between the tweet and timeline services is independent, as could be clear now from what we've been saying. But for this next interaction, what do you think is the best way for us to communicate? Again, I would say that the API gateway is not interacting with, you know, multiple services for each requested operation. Now, for the timeline service, we know it's interacting with the PubSub service, the ad service, personalization service, but not for individual operations. So I would say, again, Both tweet and timeline services are performing CRUD operations, CRUD, again, create, read, update, delete. So therefore, I would say REST is a suitable protocol here, as I've shown. Now, let me know if you agree with that, you disagree, or you have a different way you believe that we could do this. And reason why. And especially if you work at X or Twitter, I'm happy for you to, if you're allowed to, of course, don't get yourself in trouble. Comment in the box below and tell me how you do it, or how you do it. The last, so, um, so we've said that it's REST protocol, HTTP, but someone could say, what HTTP version will we use, right? There are multiple versions. There's 2.0, there's 1.1, right? So my decision on which HTTP version to follow will depends on the capabilities of each of the versions. Okay. So we say the request and response can consist of text-based tweets or media files. So if the response consists of also links to images or videos, which the client can retrieve from, a CDN, content distribution network, then it may seem that HTTP 1.1 is the obvious choice to use to load a single file. However, for a Twitter API where multiple files and media can be uploaded simultaneously, the compression of headers will play a positive role, which means that HTTP 2.0 may be a better fit. Let me know your thoughts. To be or not to be, HTTP 1.0, HTTP 1.1, or HTTP 2.0. In terms of the data formats, the timeline will contain multiple data formats, right? So if you're using multiple data formats to effectively serve the client, then, tweets, portions of ads, trends can be communicated through JSON. So that's a JavaScript object notation language or the data format. Images or videos can be transferred in a binary format just to save bandwidth. So browsers automatically compress JSON into binary data format because HTTP 2.0 already transmits in binary anyway. Now, for a system like Twitter, where data volumes constantly grow, people post, I think we calculated possibly 1 million read tweets a second. We would say that latency is a big challenge, right? And in terms of the design considerations, okay, let me just give a quick talk on latency. So we're going to evaluate this much later. But for latency, right, to achieve low latency in somewhere like Twitter, there are things we can do. For example, we can pre-generate and store our timelines in a feed cache. I showed the feed cache in the design and you're wondering what was that for. Now you know. We can prioritize recent tweets in the cache. So what that means is we can cater to a common user behavior by engaging with the most recent content. Something else is we can implement either cursor pagination or we can implement tweets, right? So we can either paginate using cursor or we can paginate using tweets, right? So number of tweets on a page. The way the pagination will work is it's going to use the next cursor pointer system, which is going to minimize the load on the network, minimize the load on the client, minimize the load on the server by fetching data in manageable chunks. Something else we can use for low latency, and we will discuss this in the latency evaluation section, is we can dynamically generate links to popular data like, say, images, videos, scripts that will direct users to the nearest CDN or content distribution network. I think the final thing we can do to achieve low latency is we can ensure APIs are client adapting. So what that means is that they can efficiently fetch or retrieve data based on the client's capabilities. By client now, we're referring to the browser and network conditions. This way you can optimize the user experience. Now, the overall aim in this approach to managing latency is to optimize data storage, optimize ranking and retrieval, and optimize delivery. So just to summarize what we've said in terms of our design considerations, we've said for the architectural style from client to API gateway to be REST, same way for gateway to backend REST. We've said the data format will be JSON, and we've said the HTTP version we prefer 2.0. Now, take a picture of this and let me know if you agree with this or you would do it in a different way. I'm keen to hear, I'm keen to learn from you as well. In terms of the NFRs, right? If in terms of the NFRs, right, we have familiarized ourselves with, the Twitter API design. We've looked at the functional requirements, how that design helps meet the functional requirements. And now it's just to give ourselves some few pointers with respect to the NFRs. So for instance, availability. Do we expect to see loosely coupled services which will run tasks concurrently and statelessly? Or do we expect to see monolithic services, right? So an example of a loosely coupled service is the usage of the PubSub between the tweet service and the timeline service. If you remember our diagram, that's what we showed. You can just rewind 2 minutes ago. And I was trying to explain that the reason why we use the PubSub service is that it allows us to decouple the tweet service that we're designing and the timeline service. And then, it allows us to deliver multiple concurrent tweets in peak time. So to access the Twitter API for a certain period of time, we can use rate limiting from the API gateway. That's one way to improve availability. For reliability, the main thing we're trying to do here is we want to eliminate single points of failure, okay, or what we call SPOFF. And one way to do that is by using what we call the back end for the front end approach, right? And this will make our API gateway more reliable because then our services will be used by different clients. So think mobile clients, websites. And then if the Twitter service is down, then what could happen is that the service on the mobile application will not be affected by the service on the web browser because we've decoupled those services. And that's how BFF helps, because BFF handles each front-end client separately. In terms of security, we can do a mixture of push and pull. For the timeline updates. The expectation is that the Twitter service that we design will authenticate and authorize users using their credentials. So box standard, you expect that credentials will be encrypted through HTTPS or TLS. And, typical users will authenticate themselves using like basic encode/creds. And if you don't understand any of these terms I'm using, inbox me, let me know. We can work it out together. I can explain further if you want. There's something called the PKC mechanism for authentication, particularly with third-party logins. That's something that can be used for security. For scalability, because HTTP is stateless, this allows us to divide the load, right? Incoming requests across multiple servers. That's the benefit, one of the benefits of being stateless. Low latency, I've discussed this in detail previously. Pre-generating timelines, storing in feed cache, pagination, whether it's tweet pagination or cluster-based pagination, use of CDNs, quite a few. So a summary of our NFRs, if I can get myself out of the way, is for availability, you want to use API monitoring tools to detect quirky behavior, rate limiting, something else, caching, such as feed cache. For reliability, you want to eliminate SPOF, single points of failure. You want to use the back end for front-end patterns so that you can debug clients on different types. You can use circuit breaker as well, so you can use all three. For scalability, you can use a hybrid push-pull model, as we described, and then you can route the request to any replica service, so that's redundancy built in. For security, we said you should carry out basic authentication via user credentials, user credentials. All this happens in the background, right? You just come in, you log in, and then it goes through because in the back end, authentication has already happened. Maybe your device already saw the cookie. Or authenticate and authorize via the OAuth, OIDC, and you can use TLS for secure exchange of data, low latency, caches, of course, paginations, Go, CDNs. Let's do this. And just to give you a bigger view of the NFRs. Okay, so to recap, we have looked at, with previously in part one, we looked at functional requirements and non-functional requirements and supporting services. In this, we have now looked at our API design decisions, so the things that will influence our FRs and NFRs and the workflow between the different components. In part four, we'll look at the API model. As usual, like, subscribe, let me know if you design Twitter/X any differently. Let me know if there's any tech or platform or service that's popular, maybe Facebook, for instance, that you'd want me to look at in my next videos. I'll be happy to oblige.